our software had to be deployed and be air gapped from the internet. So
Mm.
that separates us from your standard SaaS company where, hey, we want to sell you this enterprise application and we need all these fingers and touches into your system. So we need to expose you so that we can do what we do. And that's not at all how our business model functions is we bring the software to you. It stays air gap, you manage it, you own it, you take it. We train you on how to use it, and we can build the models for you that actually.
Today, I brought on Phillip Hansel, co-founder and CEO of a Techstars company called AIOps. AIOps is an AI ML solution for the heavy industry to implement real-time optimization while maintaining air-gapped security and minimal operational disruption. Phillip brings to AIOps almost 2 decades of experience in control systems within the heavy industry as both an engineer and manager. Phillip quickly recognized the transformative potential of AI in heavy industries, and today we discuss why that is and how his startup AIOps is redefining optimization and control systems. This is Earth ABC, featuring Phillip Hansel. Welcome to the show, Phillip. Let's jump right in. What's the big problem your company AIOps sets out to solve, and how did it all begin?
Yeah, so AIOps really got started around the whole concept about machine learning and AI, and specifically in heavy industry and commercial industry for control systems. Is it going to have a place there? Does it need to be there? AI is not necessarily for everything in all places. So all the way back in 2019, we sort of set out to solve whether or not it had a real, place in our industry for real-time control. And pretty quickly, we figured out that it definitely has that place. The one key area that AIOps has stepped in is not only in the expertise of what it takes to do the modeling techniques, but the inferencing platform that really needs to exist on these real-time control systems to make inferencing, machine learning, and AI a real possible thing. So what we do is we provide the Kiosk platform. It's a highly reliable, very scalable and sustainable application that makes it easy for real-time and frontline engineers to implement AI algorithms directly on their control system.
Sounds good, sounds good. And before our conversation, you mentioned the term heavy industry. What does that refer
Yeah,
to, and who are the stakeholders there?
yeah. I mean, really, almost anything that you can think about of heavy industry would fall into that category when you think of industry. So that could be oil and gas, could be agrochemical or bulk chemical processing, mining and minerals, food and beverage, wastewater, utilities. All those folks are what we would be considering heavy industry. And believe it or not, AI and control systems has a play in each one of those verticals. So optimization and the capability for optimization exist in each one of those areas.
So when you mention optimization and control systems, I imagine it's something to deal with like process optimization.
Yeah, so a lot of these facilities have gone through optimization processes already. So if we were to wind this back, many, many years, controls has been through many different evolutions. Recently in the 90s and early 2000s, everybody migrated off of what was called old pneumatics to the full digitalization of their control system. So you have modern controllers, you have modern instrumentation. Throughout the years, this instrumentation and these control systems have become smarter, but largely the algorithms that do the control have all stayed the same. And so we do have advanced techniques that are available to us today. Advanced process control, or APC, is one of those subsets of control engineering that really handles that form of optimization. And AI is now weaving its way into that subset, right? So it's going to become its own extra tool in the toolbox for those engineers to perform optimization.
Mhm. And you mentioned before that you were trying to explore if AI has a place within this industry, not to mention that you found that it does have a place very quickly. What did
Mm.
that exploration look like, and how did you find like the real big need here?
Yeah, so for for AI, and specifically what we were looking into was a subset of machine learning called deep reinforcement learning. Um, and so what we were looking to do is, can you even build reliable models that could have a high enough control fidelity that you can take them and deploy them in the real world and they actually function? So one of the things about doing deep reinforcement learning, to be specific, is that you actually have to let the agent explore its environment and make random moves. You can imagine that if you're, a gas plant owner or operator, you're not going to want to let anything take random moves on your system, right? There are personnel, there are people, there are equipment. There's a community that lives around you that would all not want that to happen. So the very first problem we had to solve is, how do you train deep reinforcement learning agents when you can't train on the live system? And so we found out a couple of techniques there that we sort of honed in on that would let us train these agents offline very quickly by replicating the physical systems using another subset of machine learning techniques. And then training that agent with an optimization um, sort of reward system or cost function associated with it. We quickly realized that we can actually do this. We can train deep reinforcement learning agents offline on high fidelity simulations of the physical system, and then take that result and deploy it on the platform that we built, which makes inferencing very easy and manageable to deal with, and deploy them directly on the control system for real effect. So that was the big leap for us, is that it's all great when we're just filling in sentences in our emails, or, writing our homework papers and all that stuff. But if I want to squeeze out more barrels per day, or if I want to, you know, uh, greatly reduce the time it takes to get a certain process on spec, and I want to use AI to do that, what's the tool sets for that engineer, right? Those things don't really exist, or they didn't. And so that's kind of what we figured out pretty quick, is that you can do these things. They do apply, and they have a lot of longevity when you build them. So the sustainability of the optimization that you put in place is just as much a part of the optimization as the actual algorithms themselves, right? If I have to constantly come in and update or change or tweak or make adjustments to this algorithm that's in place, I'm peeling away those layers of optimization each time I do that. And so I want to make sure that what I deliver is going to be there for a long time with minimal touch. And
Right.
deep reinforcement learning gets you there.
Pretty spot on. Like you want it to be like as hands off for maybe like a managerial person within the business to ensure like they're constantly having like process optimization within their systems. Mhm.
Yep.
And then for the heavy industry, like what comes to mind for me is like it's much older than like the latest like AI advancements. And so like you have this discrepancy between like older like hardware technology and like newer like software technology. And let's say for someone who doesn't have like a technical background in like hardware or software, how would you describe your main product?
Yeah. So the main product, the Kiosk solves a bunch of problems, but the first one we talked about, where we make it possible to do the real time inferencing on control systems. The part of solving that problem was putting it in a place architecturally on the network that it makes sense for those customers. So um, one of the things that you can imagine is that you're correct that the software and the hardware is not set up in such a way that it's going to have the resources on board to be able to inference models at scale. And so when we deploy the Kiosk application, it's on a hardware agnostic Docker deployment, and we can put it directly on their controls network. The biggest thing that we had to do to really make this viable to the end user, so the gas plants, the chemical plants, et cetera, is that our software had to be deployed and be air gapped from the internet. So
Mm,
that separates us from your standard SaaS company where, hey, we want to sell you this enterprise application and we need all these fingers and touches into your system. So we need to expose you so that we can do what we do. And that's not at all how our business model functions, is we bring the software to you It stays air gapped. You manage it. You own it. You take it. We train you on how to use it, and we can build the models for you that actually inference on that system. So um, that's kind of how we bridge that gap, is that we know that the hardware and the software that they have is not capable. And we also know that they do not want to be exposed to the outside world from a network standpoint. So we basically sit on a supervisory hardware or virtual appliance or however they just decide to deploy us. And we stay air gapped from the system.
Mm.
So
I think
they can manage it all internally.
Yeah, the fact that you guys can be usable by your clients like offline, and then also just agnostic to hardware and software, given like you're using Docker. Are there other specific features or capabilities of your product that you think are game changers for your customers?
Well, Docker being one of them, the whole concept of being a portable app and being able to port from one place to the other is going to be a key feature for heavy industry control systems in the future. The concept of having fixed assets, say like hardened controllers, hardened switches, those kind of things that are physically residing at your location and are heavily expensive, take deep investment to get installed. That kind of stuff is going to become less and less of a thing. Yeah, the Docker would be a big game changer for us. And then, on top of that, the portability of Docker. So being able to move the application around at scale. And then it also helps us keep our price very, very low.
Yeah.
So these customers, they're going to have to have these kind of technologies at their fingertips in the same way that you and I can download stuff on our cell phones and have apps. Their capital exposure that they can go out and spend and invest really isn't as big as everybody thinks it is. They need efficient, cost-efficient applications just like you and I do. And so that I think that because of our approach on a single Docker container, we can deliver to you so much and do it at a cost-effective way and put it on your network completely air gapped is the big game-changing feature for the customer and for us.
Yeah, and I want to talk numbers right now. I saw on your website you put out that there's a 600% on the typical return on investment. And that's an insane return, and it adds only less than 1% to like personnel management workload. And to me, like that sounds too good to be true. But I want to ask, like, how much does your solution cost, and how soon can someone break even from their initial investment?
So a lot of the customers that we work for, what we call, high volume but low margin. So the volumes there are very big and the margins may be somewhat small. So if we're getting a 1 or 2% gain on an application, if you extend that over a year, it's a large number by the end of that year. The application itself, the Kiosk system, is only $74.99 a year, so $7,500 gets you the Kiosk system. On that system, for the guys and girls that are out there, you get Ether IP drivers, OPC drivers, Microsoft SQL, SOAP, XML, REST. So you can connect to many different devices. We don't limit you on the number of devices. And depending on the kind of hardware that you install us on, for example, a 4-core CPU with 8 gigs of memory could run you anywhere from 250 to 500 models at a 1-second scan rate. So that's 250 to 500 opportunities of optimization is the way we look at that. So when you think about the overall cost of our application, that 600% return on investment, as far as what the cost of the application is probably a low ROI estimate, right? Because a lot of these um, applications, I'll just kind of throw some of the things out there from some of the customers. They may have, $30 um, of margin per barrel of oil, for example, or jet fuel that they may extend out to the market. And what they want to do is recover, say, just something like 100 extra barrels a day. Well, that totals up very quick, right?
It does, yeah.
Even at the $30 per barrel. So for us to be paid, we can get our return on investment oftentimes, within a couple of months to 6 months. Worst case scenario is, a year or 2 years.
I see. So companies that are pretty much like really big and can scale from um, opportunities of process optimization for a bunch of their units, like they'll reap the most benefits.
Yeah, now there is an engineering cost that extends with it, right? Because the models still have to be built and they have to be sort of validated before you put them online with the Kiosk application. The Kiosk application is by far the cheapest part of the equation at 7,500 bucks per year. Engineering for these kind of scenarios can range, anywhere from 30,000 to, $300,000 per attempt. It just depends on what application you're going for. So the scale factor, when you mention the scale, let's just take, say, a multinational company that's got, plant assets all across the world. How is it that that becomes feasible for them to say, okay, this one application works for me over here, but does it generate enough return on investment to where I can replicate that at the next plant and the next plant and the next plant? So part of that strategy that we see, which is another product we'll be rolling out here at the middle of 2025, which is our Ronin platform, is the ability of these engineers to build and train their own models using the techniques that we've sort of built out ourselves and have been very successful at. And so that feeds into that sustainability model of now the customer can build their own optimization, manage their own optimization with their own internal costs without having to go out to outside contractor help every time. And so that extends that ability for these guys to scale. And for us, that's what's important, because if the end user cannot develop their own applications, which is what they have done throughout their entire existence, they have always kind of taken pride with owning their own capability to handle their systems technically. If they don't take that up and run with it, then the scale will never actually be there.
That's
They
true.
have to be able to build these. Yeah.
Yeah. So walk me through how AI Ops implements its solution for like any given customer. Let's say I just reached out to you expressing interest in adopting your solution. What happens then? Like, and then all the way up to me seeing a boost in my energy efficiency and like process uptime.
Yeah, so we'll take like a simple scenario. Let's pretend that we're, say a grocery store. Just to kind of give you some concepts of a grocery store. Um, about 30% of their overall energy use is in their refrigeration systems.
Oh, wow.
Yeah, so the ice cream, the broccoli, the French fries, all that stuff is 30% of their power bill every month. And so part of that is operating the refrigeration systems in a more efficient manner. So if we were to go in and take a look at some of the refrigeration units there and see if we couldn't stabilize some of those things, how soon would it be for those guys to be able to see a return on their investment? So the first thing we would do from a project standpoint is, determine whether or not we need to deploy with these guys on prem. Do they have the data that we need to actually build the models? So some of the customers just don't have the data, so we have to install first. Then we record that data, and then as we capture the data, we come out, export it, build the models that we
Mhm.
need to build, and then we can deploy it back down on the Kiosk system and interface that with their existing control system. So if we were able to save somebody, just say a 3% or a 7% return on their energy usage, that is more or less of what we would be calling the break-even point there. So if your overall expenses at the grocery store to run all your power was 30 grand, and 30% of your expenses, so 10 grand a month, was in refrigeration, anywhere from $300 to $700 in savings on your compressors that it takes to refrigerate that stuff would be enough for us to cover our costs there.
Mhm.
Um, so that's kind of how we take a look at it with a customer, as we first define what their problem sets are. Boiler applications, so like maintaining level within a steam drum is huge, especially as things change, because you're changing your ability for heat transfer if you can't control the volume of water in the vessel. So that would be another very clean application to kind of go after right there, is that we can hold that more stable than traditional three element control
Mhm.
for boilers, and thereby reduce amount of fuel it takes to heat the water, reducing your emissions, the whole thing, and your buyback there is pretty quick.
Yeah, I
So,
appreciate you using the example of grocery stores. Um, I think it's pretty easily digestible for any given listener, and I'm very surprised that ice cream takes up that much to kind of maintain. I say that half jokingly because there's obviously other stuff for refrigeration. I want to pose two like situations at you, one software related and then one hardware. So for the
sure.
software, let's say I already have my own like AI model, and it's doing
Mhm.
quite well for me. And like many, I'm always open to further improve my like industrial processes. How would AI ops and I explore a potential partnership? And can your solution incorporate my own AI model that I already invested so much resources in?
Yeah, so that's actually how the company got started.
Mm,
So one of the co-founders built a model for the company he was working for at the time, and it was predicting the process quality, the quality of the process at the back end. And he said, the only problem is that it runs on my computer. And he said, I want to show this to the operators in real time. And I was like, well, I can fix that for you. And many months go by, but of us actually developing the first version of the Kiosk. But that's how the Kiosk got started. So yeah, our prime partner, our prime customer is that customer that has the data science capability to build their own models. And what they're looking for is that reliable, sustainable platform that they can deploy it on and interface it very quickly with their control system, have the bidirectional relationship, so data in, data back out, either for control or enunciation on the operator board. But that person and that company is the prime partner that we're looking for. The models that we execute on the Kiosk, just to let you know, are TensorFlow Lite. We use the TensorFlow Lite runtime framework as our runtime. Super lightweight, super basic. We build everything up around that. And so most models out there, whether they're H5 or Onyx or PyTorch, we can get those converted down into TF Lite and upload them into our system.
mm. And so let's say on the other hand, like I have a bunch of hardware that helps me oversee like how my hydro treater unit is operating, right? And
Mm.
so I have like pumps and coalescers like off the shelf, and let's say I have a custom design like reactor vessel. In that case, and similar instances where I have like a mix and match of off the shelf hardware and custom design hardware, how compatible is my system with like Kiosk?
Sure. So one of the things that we decided early on is that we not only did we want to make the Kiosk system portable and hardware agnostic, but it needed to be cross compatible with existing systems that are out there. So the protocols, when you install the Kiosk, it installs as a network device. So it sits out on the network. And most control systems today operate on some form of Ethernet protocol or communication. That may be what we would call OPC UA or Ether IP is another one of the very common protocols that are out there that we interface with natively out of the box with Kiosk.
Mhm,
So if your control system's got that application and got that protocol capable, we can browse all your data and pull it in and write to it straight out of the box. So it's pretty easy for us to get in and get right to work.
mhm. And like other than process optimization, like um, providing a company with a bunch of like cost savings, I'm familiar that this also helps with reducing like carbon emissions and stuff like that. So what are like the upsides of carbon reduction within the heavy industry?
Well, I mean, it's tremendous. So it, I like to say it to customers all the time that there's always a side effect to optimization that you never expected.
Right, right.
And oftentimes it's not just the bottom line that gets improved, it's the overall consumption of materials that you're taking in and the cost of that consumption. So just because you're pulling in some raw material and you're using less of it, you're now putting less strain on the market and the supply chain that it takes to do that. And those things to get to you take and require a lot of energy as well. So from the supply chain down, and then from the emission side, when you talk about the things that you burn, because we still have a lot of that going on in heavy industry, and to be expected too, based on what we're doing. So your true emissions that leave the stacks get improved, as well as the consumables that you're taking in get improved. And one of the things I like to lean on is the big supply chain issue that we had in the early 2020s. Where it was very difficult for folks to get material or exchange things back and forth. If you're using what you get better, you're isolating yourself from those kind of risks, right?
Mhm.
So I think that not only does it go to an environmental standpoint that you're just using less, and then you're putting out into the environment less, but you're also exposing yourself to less, of a downside of a supply chain issue, et cetera, right? Because you're much more efficient with your capabilities.
Right. And then there are probably people that recognize that carbon reduction isn't like the only thing um, that is like a benefit, right? To like the bottom line of things. How is AIOps like uniquely approaching the carbon reduction problem?
So we have some opportunities I can't quite talk about, but um, whenever it comes to emissions, for example, going back to the boiler use case that we mentioned, improving combustion control over a packaged boiler. So steam is the bedrock to most heavy industry out there. They use steam for all sorts of applications. So running that steam system more optimally is going to be hugely beneficial when you think about how much fuel gas you're going to be burning to create that, right? That mass to mass exchange there. So just that alone is one areas that we're diving into directly and optimizing the package boilers that are all over the place, such that they are able to provide more stable steam delivery. And as a result, their combustion control is much more efficient. So we're hoping to claim something to the tune of like a 5 or 10% improvement on emissions, even on clean burning package boilers with flue gas recycles and everything.
Mhm. Yeah, I think it's quite evident now to see like how much your company is helping to optimize like these processes and making it as easily adoptable as possible, given how you're agnostic to industry for OEM and then also just for like software too.
Yeah.
And before we end, I'd love to hear about like what's next from the man himself. What exciting things can we expect to see and hear about AI ops in the near and distant future?
Yeah, so we're still continuing to grow. Very very exciting future for the company itself. But product wise, as I mentioned earlier, we plan on releasing the Ronin training system. That'll be our first true SaaS application. That'll be responsible for actually training these models. And the place that we're filling, the need that we're filling there is, the thing that companies like C3 AI or ML Studio, SageMaker, Palantir Foundry, these companies are not filling for the customer, right? So it comes down again to that sustainability of sustaining and building and maintaining your own form of optimization within your own company. So kind of owning your own destiny there. We're bringing that and putting that into our customers' hands mid-year 2025. And for us, I think that's going to be even a bigger splash than the Kiosk, and even doing deep reinforcement learning for closed loop control and optimization. Having the Ronin system in the customer's hands is going to be the game changer.
For sure. This was really exciting to learn about like Kiosk, all the great impact that you bring for these like companies in the heavy industry. And yeah, can't wait to see how the Ronin system gets applied to all these like different companies as well.
Yep, no, we're looking forward to it. Thank you.
All right. Thank you.
Thanks for tuning in. If you enjoyed this interview, follow along on EarthEBC's LinkedIn to stay connected and never miss what's going on in climate tech. If you'd like to reach out or you're interested in coming on as a guest, feel free to connect with me, Sean Pack, on LinkedIn. We're always looking for inspiring ventures and founders in the climate space to feature on the show. Hope you enjoyed. Until next time.